Hello everyone, and here we are for another example of electrolysis, and in this example we'll be using concentrated sodium chloride. Okay, so one thing that you must immediately notice is that we are using the word concentrated, right? And when they use the word concentrated, we must immediately take note about it. Okay, so let's go through the whole process one time. Whatever you're used to, you may want to pause to go and try to revise, right? Or you can just follow me over here. Okay, so I hope you have tried it, right? First one, negative, positive. So this is positive electrode, negative electrode, electron flows this way, electron flows this way. Then after that, I need to decide what is the ions present. I got Na plus, Cl minus, because it's a solution, so I got H plus, I got OH minus. So to the negative, positive side, I have this, negative side, I have that. So on the positive side, I have Cl minus, OH minus. On the negative side, I got Na plus, and then I H plus. So you might think, Mr. Benjamin, I already did this before already, right? Cl minus, OH minus, you tell me OH minus always at the top. Okay, however, I need to teach you a new thing is at O levels, right? Apologize to your future teacher for me. At O levels, concentration will only affect the anions. Okay, when we talk about concentrated sodium chloride, we will think, so the former sequence is like this, right? The former sequence is like this, and then sulfate and nitrate, never, right? Never. But if it's concentrated, then we will choose these ones. So only when it's concentrated, right? Only when it's concentrated will I choose this over the OH minus, but never the sulfate and the nitrates. So in this case, instead of the hydroxide coming out, right? What will happen is that the chloride, which is in the aqueous state, would produce chlorine gas. Okay? Now I balance it, and then 2 electrons on this side, so 2, and then I know this one is loose electrons, so then this is oxidation. Okay, loose electrons, oxidation, oiric, just to remind all of us again. Describe it again, I see bubbles of yellowish green gas. Okay, and then to explain, again, because I need to choose, right, because of concentration, I selectively oxidize the Cl minus. So location, reactant, reaction, and then product. So location at the positive electrode, Cl minus chloride ion is selectively oxidized to form chlorine gas. And this selection happens because we are more concentrated. Okay, because it's concentrated. Now, if we look at the negative electrode, the interesting thing here is that, can you all please write this down? Concentration at O levels only does not affect cations. Okay, it does not affect the cations reaction. So over here again, we use the metal reactivity series, and we know that it's the H plus that is being selected for. On the other side is the Cl minus, special case, Cl minus, and then H plus. Right, so the half equation will be H plus aqueous, right, form the H2 gas, and then I balance it, and on the left side I got 2 H plus, on the right side I got no charge, so in order to make sure that it's balanced, I add 2 electrons over here. I know this one is a gain, and therefore this is a reduction. Right? Description, same, bubbles form. Explanation, same, right? At the negative electrode, hydrogen ions is selectively reduced to form hydrogen gas. Right? So then the next one that I talked about previously is that remembering if I need to label cathode and anode, CRAO, cathode reduction, anode is oxidation. So at this negative electrode, because reduction has occurred, I know that this is the cathode. because cathode is the electrode that reduction occurs. And then my positive electrode oxidation occurs, so this is my anode. Okay, so that's very good. So just one last thing to add over here. Let's see. As the electrolysis occurs, okay, I'm going to write this in another color because this is important. As the electrolysis occurs, the Cl minus decreases, the H plus decreases, right? Keeping the Na plus and the OH minus there. So, as the electrolysis happens, the pH will increase. Right? This is important. Why the pH will increase is because while the concentration, OH minus concentration remains the same, but the H plus concentration decreases because the H plus is becoming H2 gas. So OH minus concentration remains the same, but the H plus concentration decreases. So the concentration of OH minus will gradually get more and more and more than the H plus. So therefore pH increases. If I add universal indicator, it will turn blue, then purple, right? Litmus paper will turn blue, right? So it becomes alkaline. Alright, so this is something special for this. Please take note about everything over here. Practice, practice, practice. Remember, concentrated will change the anion reaction. Alright, all the best.